This is section 6.1b. So let's look at this problem. It says y equals cosine x. And let's go with purple. Y equals 2 minus cosine x. And it gives you bounds from 0 to 2 pi. It says 0 is less than or equal to x, which is less than or equal to 2 pi. So let's start off here. Cosine looks like this. Mine's not quite drawn to scale, but not quite symmetrical. So here we have 0 to 2 pi. And then we have 2 minus cosine x. So y equals 2 minus cosine x means the negative cosine x flips it upside down, like this. And the 2 means it moves up 2. So the center is up 2. Well, right now this is at 1 and this is at negative 1. So I didn't do a very good job of drawing this. So they're gonna pop like this. So it's reflected, and the center of it's at 2, and it goes up to 3. So this is actually a pretty and a fun graph in my opinion. So I've labeled them with colors, and I think the point of intersection is pretty easy to see at 0 and 2 pi. So they don't always give you the points of intersection, but we're going to run with it. So we have 0 and 2 pi. The top one is the purple one, 2 minus cosine of x. And then we're going to take away the black one, which is cosine of x, all with respect to x. Let's switch to brown. So we have the integration from 0 to 2 pi. Combine like terms. 2 minus 2 cosine x dx. Now this is a nice, easy integration. I like this one. When you integrate 2 with respect to x, you get 2x. Minus 2, when you integrate cosine of x, you get sine. So 2 sine of x from 0 to 2 pi. So when we plug in 2 pi, we have 4 pi minus 2 sine 2 pi minus 0 minus 2 sine of 0. Now you need to really truly write those out and think about them and make sure that what your assumptions of 0 are true. So we have 4 pi minus 0 plus 0. So the answer is 4 pi. Nice, easy problem. I picked a good one there. I would really like to show you one that switches in the middle. So I can't think of one where it switches. So let me just give you an example here. Let's say that you have some trigonometric curve. Let's say cosine of x. Okay? So this is y equals cosine of x. And we know that it's from 0 to 2 pi. And let's put a horizontal line here, and it's y equals 1/2. We know that won't be too difficult to do. And we're finding the area between these curves. So see how the area between these curves switches as to which one is on top? I would like to set this up and not do this whole thing. My y equals 1/2 is very crooked. Remember, it's a sketch. Don't hold it against me. So we need to know what this x value is here and what this x value is here. And we have x equals 0 and we have x equals 2 pi. So it divides this graph, it divides this problem up into 3 parts. The first one, the last one, and the one in the middle. Now, they're not often going to have you do the whole thing, and since we're making this problem up from scratch, you're not going to find it anywhere. It came out of my head. Let's stop it at pi. So let's rebuild this problem. And let's say y equals cosine x and brown y equals 1/2. And your bounds are 0 to pi. Now, a lot of students just want to go ahead and do 0 to pi and not draw a graph. It is not a good idea. So we draw our cosine graph, and pi is in here. Oh, I did it in the wrong color. As I color code, let's switch it. Y equals cosine x. All right, and then let's put in y equals 1/2. This is our y-axis, this is our x-axis. I got sloppy with my labels. So this is x equals 0, and this is x equals pi. But do you see that when we find we haven't drawn the other line. So this is the line y equals 1/2 right here. And this is y equals cosine x. And the purple shading is the area between the curves. So we're going to have to do two integrals because one of them is, in one of them, the brown curve is on top, and then the other one, the blue curve is on top. So we're going to say that we got to find this point of intersection right here. We set them equal to each other. Cosine of x equals 1/2. That looks like a nice, easy, basic trigonometric function, right? Something that we learned in basic trig. So we know that x equals pi over 3. So right here, x equals pi over 3. So our three x values are x equals 0, x equals pi over 3, and x equals pi. So we're going to start with the bounds from x equals 0 to pi over 3. And when you look at this one, the brown curve is on top. So we have cosine of x minus 1/2 with respect to x. And then we're going to add the other integral. And it's going to be from pi over 3. We got to pick up where we left off. And the shading's going to stop at pi because I colored too much. But we're only going to pi. So this is what's important here. And we're going to do, in this case, the blue line, the blue line's on top. So we have 1/2 minus the brown curve, which is cosine of x dx. So we have, so the integral of cosine of x is sine of x, minus the integral of 1/2 is 1/2 x from 0 to pi over 3, plus, I was going to write an integral symbol. When you integrate 1/2, you get 1/2 x, minus the integral of cosine of x is sine of x again. But what's important here are your bounds. You have different bounds, so we have different values that we're plugging in. You can't just say, well, it's going to double or whatever. When you look at the graph, even though it's a sketch, it's obvious. It's not the same. I wouldn't say it's obvious. I think you kind of have to know a lot of trig to see that. All right, so let's plug in pi over 3. I think it's easier to actually write it down and then go back and do it. So sine of pi over 3 minus 1/2 times pi over 3 gives me pi over 6, minus sine of 0 minus 0, plus 1/2 times pi is pi over 2, minus sine of pi, minus 1/2 times pi over 3 is pi over 6, minus sine of pi over 3. So here we have the square root of 3 over 2 minus pi over 6. The sine of pi over 3 is the square root of 3 over 2. Minus 0 plus 0. Good to think about it. Pi over 2 minus sine of 0 is still 0. Minus pi over 6 minus the sine of pi over 3 is still pi over 3 over 2. I'm sorry, square root of 3 over 2. So we have the square root of 3 over 2 minus pi over 6 minus 0 for both of those, plus pi over 2 minus pi over 6 plus square root of 3 over 2. They do come out to similar values, subtracting in different ways. So common denominators. Now I'm only really doing common denominators with my pi values because the rest of them can't be combined with it anyway. So we have negative pi over 6 plus pi over 2 can be written as 3 pi over 6 minus pi over 6 plus square root of 3 over 2. So if I add those two, I get 2 square root of 3 over 2, 2 square root of 3 over 2, and notice the 2's cancel. So we're just going to call it the square root of 3. And then negative pi plus 3 pi minus pi all over 6 gives me plus pi over 6. Now that's a beautiful answer. If you want common denominators, you could say 6 square root of 3 plus pi all over 6. I'm not sure which WebAssign wants, but I am pretty sure that we are good there. Pretty sure that you've got it. All right, and I think that's the end. I think I've shown you everything you need to be successful in this lesson. And have a great day. Enjoy doing some math.